Well, good evening. Welcome to Space Oddities. I'm afraid we're a bit thin on the ground this evening, but you're very welcome if you're here for the first time. You are exceptionally welcome, as is everybody else. Looking in the chat, I can see we've got the normal suspects in tonight. So welcome everybody. We've got quite an interesting program, I hope, lined up for you as always. I'm joined this evening by Daz and Roger and Lou. How are you guys?
Yeah,
Good.
we're fine,
Getting ready
thank
for
you.
the holidays.
Good. I'm afraid there won't be a viewers gallery tonight because unfortunately Rachel is still poorly. So Rachel, we send our best wishes to you and hope you feel better soon. So apologies for that. But as Rachel organises the whole viewers gallery, we can't really do it without her. So hopefully Rachel will be back next week. And those images that you have been kind enough to send in, and do please keep sending them in, we'll hold them over to next week. And all the best to Rachel, as I said. So moving on, what have we got today? Well, we've got quite a mixed bag today. We've got some news of the Square Kilometre Array telescope. We've got black holes. We've got SpaceX. We've got all sorts of stuff lined up today. We've got Titan, the exploration of Titan that Lou's going to tell us about later. But of course, before we get into all that, he is the man with the clearest skies on the planet. He is the man who does the most amazing lunar images, which he assures us are not photographed from a magazine, and we believe him. And of course, we love seeing them. And he is, of course, Roger. How are you, Roger? And what have you got up for us this week in the night sky?
Yes, well, I'm afraid to announce that with the full moon coming up later this week, I've got clear skies from Tuesday right through till next weekend. So let's see how that goes.
Yeah.
Anyway, so here we go for the 5th to the 11th of December. How time flies.
Indeed.
And of course, we've got the full moon, which is in the wee hours of Thursday morning. But Thursday morning will also be a special event for Mars. Oh, we'll smaller there. Yeah, okay. Well, we'll go on with this one. So this is a picture that I took in the last few days of the Flamen Horsehead here. Just thought I'd pop.
That's amazing, Roger. Wow.
I've managed to get some of the dust down through the picture as well. Considering that was only an hour's worth of pictures, I thought it'll do. It's not too bad, but I'm gonna do a wider field view of that. So there's a bit of a tight crop with that square sensor, but we got potential.
You know that when you say, "Oh, it's not too bad, it'll do," the rest of us could spend our whole lives trying to get an image like that.
Wow.
So
yeah, I think the new camera that I got, this new Player One Saturn color camera, is an amazing thing. Even though it's based on the 533 chip, it seems to have a better spec than the other manufacturers can achieve. So things might progress to other camera sensors for me to do other things. Anyway, so
yes.
on the 8th, we've got the Mars opposition. And in the early hours of Monday, we'll have the moon occulting it. So that should be an interesting event. And here we've
Sounds
got
like a bad sign, Roger. Is disaster being forecast?
Not in Sparkford, because I'll have clear skies.
Okay.
As you can see, obviously it's not as large as the previous opposition in 2020, where we had about a maximum about 24 arc-second diameters, although 17 isn't to be sniffed at. So we'll be pleased to look at that. And as you can see, from late August to middle of February, you can see how quickly it grows in size and in brightness. But we'll try and keep an eye on it for as long as we can while it's still in its position up in the Taurus region. And this is the area of where you can see this. So a lot of people in America can get it. Canadians are not a problem, as Greenland, Iceland, the UK, and the western part of Europe and Scandinavia. So that will be a good thing to be going. Clear skies allowed. So roughly from just before 5 o'clock in the morning to 6 o'clock, when we have it entering and exiting behind the globe of the full moon, we'll hopefully be able to do some imaging of that. And I'm very hoping to do that myself. I'll probably have to relocate just outside the garden for obtaining this, but it should be an interesting sight. And
Indeed. Look forward to that.
so we've got Jupiter now setting down into the southwest, and Mars achieving much greater prominence in the southern skies, with it getting up to quite a high altitude. From about where I am, it's going to be up to a maximum of about 63 degrees up in the skies. So that's a pretty good view, and should be able to cut through a lot of that bad atmosphere to get some good images. So we'll see. Watch this space. And obviously these are all done from 10 o'clock at night, and Orion is now making a strong dominant feature of itself in the southeast and southern skies during the night. So hopefully we'll be getting much better views of those objects that we all love to watch in that constellation. Okay, so going on, and of course Thursday being the full moon, it's not going to help. But
We do have
James
this.
has been doing its job again, and we've managed to see what we can spot through the atmosphere of Titan, and see what lies beneath almost. And it doesn't disappoint, does it? And here we've got some ideas of what we are trying to decipher from these images. Okay.
The clouds are great, aren't they?
Clouds, yeah.
Just you're looking at clouds on a moon of another world. It's just beautiful, absolutely beautiful.
Yeah. Methane clouds.
Methane, indeed. Yes, not clouds as we know them, but they are there, and you can see some of the surface features there, which we've only really seen in any detail now with the radar of Cassini. So it's great to see these in the infrared as well. So that's
radar and the Cassini VIMS, visual and infrared mapping spectrometer, saw very well down to the surface through the methane absorption lines.
That's
there are 4 places where you can see the surface. So in the infrared as well.
Yeah, absolutely. Brilliant.
Okay, chaps, that's my part done.
Okay, great. Well, thank you very much for that, Roger, as always.
Okay.
Always a good start to the program. And let's move on. Now, which one of you guys here on the panel, and indeed those of you at home, who's seen the film Contact with Jodie Foster? Did you enjoy it? Great film, eh? I thought. Yes. Anybody read the book? Anybody read the book by Carl Sagan? Because it was his first science fiction novel, of course, Contact. I think it may have been his only one, actually. Don't know. But anyway, the reason I mention that is because you may remember in the film that it opens at the VLA, the Very Large Array of Radio Telescopes in New Mexico, which is where Jodie Foster, as the astronomer, discovers extraterrestrial signals. Well, when the VLA was 10 years old, a group of radio astronomers got together and said, what will there be in terms of radio astronomy after the VLA? What would we want to replace it with? What would be the natural successor to the VLA? And they hatched the idea of an enormous radio telescope, which has become known as the SKA, the Square Kilometre Array, because it will consist of a square kilometre of antennas, high frequency and mid-range antennas, split between Western Australia and the Karoo region of South Africa. Now, today is an historic day. This very day, December the 5th, it's an historic day because today, construction of that enormous radio telescope officially started. It's a very important day for radio astronomy today. So this has been 30 years in the making. The Square Kilometre Array is a project at the moment between, I think, 8 or 9 countries, but with 20 countries involved in some way. And there are over 500 scientists and engineers working on it worldwide. It's a global project. It will create a radio telescope that is incalculably higher resolution than anything on the planet at the moment. And the first phase of its construction should be completed in 2028. And today is the day when they actually dug the shovelfuls of earth. They broke the earth on the SKA today. So to commemorate that, I've got a little video, short 5-minute video that I'd like to show you about the Square Kilometre Array, because it promises to answer all sorts of questions in astrophysics, everything from dark matter to extraterrestrial life to we can't imagine what. So let me just play this short video and I'll tell you a little bit more about it afterwards. So this is all about the Square Kilometre Array.
What did the universe look like when the first galaxies formed?
Come si formano i pianeti?
How many gravitational waves are passing through me right now?
And for me, the most important is there life out there?
We're building what will be the largest science facility ever built by mankind.
What we're talking about is 2 telescopes.
These are going to spread out over literally hundreds of kilometers.
It'll stretch out beyond the horizon. Our site's in the middle of the West Australian desert, far away from towns, radio interference.
We're building hundreds of dishes in a remote location in the middle of South Africa. It's a hot environment, it's a dry environment. It's really tough.
Een project als dit kan alleen tot stand komen als wetenschappers wereldwijd met elkaar samenwerken.
We need astronomers to define the scope of the instrument.
We've got to get 500 engineers to work together over 20 countries in all the time zones in the world.
我们如何来建造这台望远镜呢？
It's like building a jigsaw puzzle. The pieces keep changing.
Part A being designed in one place fits to part B being designed literally on the other side of the world.
We've already started. We've got antennas at the site.
There's equipment on the ground in South Africa and Australia.
Imagine the amount of data that's flowing through the internet at any one moment.
Huge amounts of data.
That kind of level coming out steadily.
About a terabyte of data per second.
We'll have a total of 100,000 kilometers of dedicated fiber within the observatory.
But the greatest computing burden is to take those data streams and to make sense of them.
Every year we'll be distributing up to 700 petabytes of data. There's this huge range of science we'll be tackling. There's the technology that needs to be developed to do that science.
Practically every subject of astrophysics can advance thanks to SKA.
It's from science to technology to societal benefits. This is what engages countries.
SKA is a project that will be used for 20, 30, 50 years. You want to be part of this fantastic adventure of the human mind.
Credo che siamo davvero alle porte del futuro. La scienza parla tutte le lingue del pianeta. Il suo linguaggio connette il mondo intero.
This signature is the real beginning.
I think people will look back and think this is the moment the SKA Observatory was created.
Well, that was Sir Philip Diamond right at the end there and at various points in the video. Sir Philip Diamond is in charge of the whole project, the headquarters of the SKA has been given to the Radio Astronomy Centre at Jodrell Bank, with a new purpose-built headquarters for the whole global array. And Britain is obviously very proud to be leading that whole incredible project that is going to answer so many astrophysical questions and probably ask a lot more, obviously. Just a couple of things just to follow up on that, just some amazing facts that you may not know about the SKA. So the first thing is that data flowing from the antennas to the on-site signal processor will be transferred 100,000 times faster than the projected global average broadband speed for 2022, or if you DAS 200,000 times faster. So also, the SKA will use enough optical fiber to wrap twice around the Earth. It's an amazing engineering project. Fact number 3, the computing power required for each of the 2 SKA supercomputers will match that of the best supercomputers in the world in 2019. And in fact, this is slightly out of date because I was reading recently that the 2 supercomputers which will process all the data are both 25% more powerful than the most powerful supercomputer ever built. So these are very, very powerful computers. And each year, the volume of data stored by the SKA would fill over 1,500,000 gigabyte laptops. It's an incredible amount of data, more data flowing through it at any one moment than the whole of the internet, which is a staggering amount of data. And it will be able to be so sensitive that if such a thing existed, it will be able to detect an airport radar on a planet tens of light years away. That is the sensitivity of this amazing data machine known as the Square Kilometre Array. And the SKA is expected to be in service now for about 70 years, if all goes well, with constant upgrades. In fact, the whole thing is being made out of open source materials that can be replaced off the shelf rather than proprietary technology. So they look to the future, which meant that they'd be able to update it very, very easily. So an amazing project. It started officially construction today, and we shall look forward to seeing the completed telescope in a few years. Fantastic day, eh, guys, for radio astronomy?
Oh, that's a lot of laptops, Andy. I hope they got Black Friday deals.
Yes, indeed. Indeed.
I think I need one of those computers.
Yeah.
But yes, as you said, the data that's got to come out of this thing is going to be absolutely amazing. Of course, they've done some test trials with, I think we were talking earlier with Meerkat, Andy, which will become part of the SKA. And as we know already, the data that's collected, as soon as it was switched on, collecting gamma ray bursts, the numbers just tripled, if not more than that, overnight. It's an amazing piece of kit. So when this is all up and running, a square kilometer, it's going to be absolutely fantastic.
And as I said, there should be probably around 20 countries involved. Several countries have expressed a preference to join, perhaps in a couple of years, to join the consortium. It is an intergovernmental consortium. A lot of the effort they've been putting in up to now has been on the international agreements to allow countries to work together, to share funding, etc. So this is, yet again an prime example of science leading the way in international cooperation between countries. It's totally wonderful.
And of
so
course,
there you
the headquarters is going to be at Jodrell Bank.
Absolutely.
In the UK. So that's a thumbs up for us.
Yeah, absolutely. And if you think about it, I mean, it's the logical place to have the headquarters, because Jodrell Bank sits at the hub of the eMerlin radio telescope network, and has done for many years. And it's the obvious place because all the infrastructure, a lot of the infrastructure is already there in terms of connectivity. So this should be really, really interesting. All right. Well, let's move on then. Hope you enjoyed that video, viewers. Don't forget to like and subscribe. We really would love your subscriptions and your views and your comments, of course. Do put them in the chat. If you're watching this on Facebook, I'm afraid that when we reply to comments, you won't see them in Facebook. It's one-way direction, unfortunately, from you to us, and we can't send messages back to you. But please, we do love seeing your comments, so do put them in the chat. And from now, what we're going to do is we're going to move over to Lou. Now, we saw an image of the of Saturn's moon Titan taken with JWST, latest image. And Lou, you're going to tell us a bit about the history of exploring Titan, I believe.
I am. I'm going to start another series for us.
Fantastic.
That, like
We
we
love
had
your
when
series.
we were learning about exoplanets.
Yeah.
So we will start, as Glenda the Good Witch said, it's always best to start at the beginning, right?
Absolutely.
So we will start. Oh, I wanted to make one comment about your SKA.
Oh, yes.
I think in some respects, the real magic will happen with the sophisticated data mining and data analytics that are able to process all those tera and peta and perhaps exobytes of data.
Yes.
So just
well, in fact, when they because the United States was originally a signatory to the project, but pulled out because they thought the objectives were too vague and not that well defined. And one of the reasons was that the people who designed the SKA, the brilliant engineers, they knew that when they started designing it, the supercomputers to process the data didn't yet exist, but they had sufficient faith in technology that somebody would actually come up with a supercomputer that could do the job. And that is exactly what's happened. But the Americans, because their budget for radio astronomy is, shall we say, a little limited, and they have to support the VLA, they didn't want to sideline funding away from the VLA towards something where the actual technical specs hadn't yet been defined because the technology hadn't been invented. So, and you can understand them being a little hesitant for that. But the door is always open for them to join at a later date, and I believe there are talks going on, or have been talks going on, about them doing exactly that. So,
I hope so. Of course, this isn't a new problem. That's exactly what happened for James Webb. They had to invent new technologies as they went on.
Absolutely. But thank goodness we have people with the vision and the faith in what the future is going to bring to make it all happen. Really.
You bet.
Anyway, shall we have a look at Titan then?
Let's have a little look at Titan. So, I started thinking about this. One, because I spent a good part of my life looking at Titan, but also recently James Webb, as we just saw, the James Webb Space Telescope produced some images of Titan, little over 0.7 arc seconds in diameter.
Yeah.
And the images are stunning and are in fact still being processed. I should mention that. But the James Webb Space Telescope planetary observations are not that well publicized. We usually hear about it as discovering the edges of the universe. So we're going to start today talking about the history of Titan exploration, starting at the beginning, and we'll have 4 or 5 sessions, and we'll end up with some of the more recent James Webb Space Telescope images, and we'll talk about the science that those images are trying to tell us. So, can I do this on my own?
Yeah, absolutely.
It's not advancing.
You can page through this. If you look at your thumbnail of your slideshow, you can page through the slides there. Do you see that?
Oh, I see. Okay.
Yeah.
Let's try that.
That's it.
There we go. So this really starts back in 1655 when Christian Huygens, and you might recall the name Huygens as the Titan probe that was on the Cassini spacecraft. And that's not a coincidence. Christian Huygens, using a 12-foot refractor that he built with his brother, I believe, identified something orbiting Saturn. And this is from his observations, his notes. So you see here a picture of Saturn. On the lower left is a fixed star. And on the right-hand side of that image is a moving star, which came to be known as Titan. And he was able to derive the orbital period, a little over 16 days. And so he's really the official discoverer of Titan, and he published his work about a year later. And then I think about 10 years later, something like that, William Herschel actually named that moon officially Titan. Let's go to the next slide here. So I thought, well, that's interesting. And so I went to my Stellarium software. I guess most of you all who are with us today have some sort of planetarium software, so you can do this with yours, whatever it is. And I said, well, what would happen if I set this to March 5th, 1655?
Ah, that's a good idea.
Yeah. And there's Titan. Now it's different. If it's the orientation's a little different, right? Here we are just a little bit above the orbital plane. But if you rotate it, here we are just a little bit above the orbital plane.
Yeah.
And so it appears to be, so I verified the results. This is the first verification of Christian Huygens' observations, and you heard it here.
Fantastic.
So that's kind of fun to do. Okay.
So he did really see it then.
He did. He did. Yeah. Then we have, so now Saturn has a moon, and there are discoveries of further moons. William Herschel actually discovered the fifth and sixth moons, I think, of Saturn as instrumentation got better and better. And then around 1907, a Spanish astronomer named Solá discovered what he calls, and what we now know as, limb darkening. And this is the deviation of brightness as you move from the center of the object, in this case Titan, outward, a deviation from what it would be if it was a plain, uniformly reflecting sphere. And as it turns out, this artifact is somewhat frequency dependent, wavelength dependent, and is also dependent on the physics that you're looking at. So methane in the infrared might even produce limb brightening. And what we're seeing for limb darkening here, I think, is more characteristic of optical wavelengths and the scattering of the aerosols in Titan's upper atmosphere. But the take-home message here is that Titan, these Titan images taken by Solá were not behaving as they would if Titan did not have an atmosphere. So this was the first indication that Titan had an atmosphere. So, following on to that, Gerard Kuiper, you've heard his name before, the Kuiper Belt, that is the home of short period comets, the Kuiper Airborne Observatory that preceded Sophia, a famous Dutch-American astronomer. He, with better telescopes and better technology, was able to get a spectrum of Titan and was the first to identify methane, or as you all say, methane, in the atmosphere. So this is one of his original spectra taken here. And you see down here some identifications of oxygen and water and so on. Those are Earth's atmosphere. Remember, these are ground-based observations. So those are in the Earth's atmosphere. But over here, bandes du methane, methane band, you see methane absorption. And that turns out to be methane in Titan's atmosphere. And we know today that in the troposphere, below about 40 kilometers, Titan has a higher troposphere than we do. Methane is the dominant volatile in the atmosphere. And so there's quite a bit of it. And that was really the linchpin, the clue that said, aha, not only does Titan have an atmosphere, but methane is an organic. And that makes Titan very interesting. In fact, interesting enough that when they launched the two Voyager spacecraft, which we'll get to next 2 weeks from now, they actually sacrificed the Voyager 1 spaceship Voyager 1 spacecraft so that it could get up very close and personal to take very high resolution spatial images of Titan. So Titan is truly an amazing world. We might even call it a sister planet to Earth. And we'll be talking about all the ways that it's like Earth and all the possibilities for perhaps life in our future meetings. So we'll hold off for next week for the rest of this.
Thank you very much, Lou. It is an amazing world, and I think we've only come to realize that's obviously since Voyager. But even Voyager, we still didn't have a clue what was under those clouds. And
you know what's interesting about that, Andy?
What's that?
We often say that. In fact, even planetary scientists often say that. But that is not entirely true. The Voyager spacecraft had an infrared interferometer spectrometer called IRIS, right?
Right.
And IRIS had about a 1/4 degree field of view and was able to see in the infrared in these spectral windows where you can see down to the surface. Now, IRIS wasn't an imager, so we didn't see the nice images that we get from the VIMS Cassini. But in fact, if you do a little work and don't mind some really crummy spatial resolution, you can see down to the surface with the Voyager IRIS spectra.
Now that I didn't know. I shall have to investigate that. Thank you, Lou. That's interesting. Do you know my favourite? Well, apart from the image, the famous image taken from the surface by Huygens, my favourite image, and I'm sure you know it, is the one where there's the glint of sunlight off one of the lakes, demonstrating conclusively that there was liquid on the surface. That was amazing. When I saw that, I thought, goodness me, that world's interesting.
So that was the full development of Kuiper's observations, right?
Yeah,
because that liquid had to come from somewhere.
Yeah,
and it came from condensed
all culminated then. Amazing. And of course, which I'm sure you're going to talk about in due course, we have a helicopter going to Titan, Dragonfly, which I think is due to land. Was it 2034? I think it's due to land, something like that.
That sounds about right.
Yeah, it's about the size of a small car, isn't it? And it's going to basically hop over the surface of Titan and find out what's going on. And and
the
I was
atmosphere being a lot bigger, it can support the weight, can't it? It's going to have smaller blades in comparison to its actual main body.
That's right.
Because the atmosphere is a lot thicker, so you don't need such a long blade span, if you can call it that. Rotor arm span. So it's going to really be interesting when that happens, and to actually be able to move around from point to point is going to be absolutely fantastic.
It's the opposite problem, isn't it? It's the opposite problem that we have at Mars. Titan's atmosphere is about 1.5 bars at the surface, and Mars is about 1%. So, but we're flying around other bodies. That's pretty cool.
Yeah,
exactly. And with it being that size, we'll be able to pack it full of instruments, so we're going to get hopefully lots of data back. And of course, Bernard's our Oceans of the Solar System expert. So it's a shame he's not here today.
Yeah, but I'm sure he'll want to talk to us about that. But this lovely image of these lakes of liquid hydrocarbons on Titan, and I've seen some lovely science fiction paintings done by artists to represent them. And then it turned out that it's reckoned that the biggest wave on those lakes that could ever occur will be about 2 millimeters high. So this idea of the crashing hydrocarbon surf on Titan isn't accurate, I'm afraid. Because
no surfing, dude. No surfing.
Yeah, there's no wind to whip it up, or at least not at ground level. There isn't. So there we are.
So don't go there for the surfing.
Yeah, there we are then. Alrighty. So anyway, hope you enjoyed that. Thank you very much for that, Lou. We shall look forward to the next part, obviously.
Can I just point something out, Andy. On the first slide of Lou's, Christian Huygens, there was a small image of Mr. Huygens in the bottom right-hand corner. Now, I'm sure, actually, that was a mistake, because I'm sure that's you in the 70s with your Kevin Keegan perm when you had hair.
Ah, yeah, could well be, actually.
Yeah,
Could
it's
well
cunning. I
Good
thought
point.
slip the slide in there. When Andy had hair.
A
Yeah,
handsome guy, though. A handsome lad.
absolutely. In fact, in our village, we have a guy who, to this day, has a Kevin Keegan haircut. And I kid you not, and he looks like Kevin Keegan. And he walks around like that, and he's completely unmistakable. And he must be about 60 odd, but he's got a Kevin Keegan haircut. So there you are. Old habits die hard, I guess. All right then. So just moving back then. I think now what I'd like to do, just to take us through a bit of news that's been going on this week. SpaceX had a successful static fire of Booster 7, and this time it was an 11-engine test. There didn't seem to be as much concrete rain falling afterwards as the previous test, so this new coating that they've put on the underneath the rocket seems to be more durable than the previous one. And they've actually put a coating that is meant to withstand 1100 degrees Celsius. But there was still a bit falling. But anyway, here's the static fire. This is speeded up. Quite interesting to watch the frost line moving up the rocket as the fuel tanks were filled. First of all, the liquid oxygen, and then the methane. So here's the static fire. This is loud, I warn you. So there we are. So that was the static fire. 11 out of 33 engines, so a third of the total capacity, and it still was that loud and created that much dust. A phenomenal static fire.
All that didn't go anywhere.
Well, yeah,
there.
They're working on that.
Okay.
They'll get there eventually. But of course, they are hoping to get the Super Heavy booster and the Starship into orbit sometime this month. I don't know whether it will happen. It would be good if it happened on the anniversary of the JWST launch on the 25th of December. That would be lovely, but probably not going to happen. What else have we had going on this week? Well, we have had... let's have a look. Black holes have been in the news. Astronomers detected a rather perplexing flash of light from an extremely distant galaxy whose light has taken 2/3 of the age of the universe to get to us. And it turned out that this was a supermassive black hole swallowing a star, and its light has taken about 8 billion years to get to us. This is an artist's impression of what I think happened. The star strayed too close to the supermassive black hole and was consumed. This event was unusual because it was detected during an optical survey. Normally, these types of events are detected in radio or X-ray, but this was an optical flash that turned out to be a black hole swallowing a star completely whole about 8 billion years ago. So really interesting stuff there. What else? SpaceX, unfortunately, have had a few problems launching the Hakuto R moon lander from Japan's iSpace company. This is the first commercial lunar lander to go to the moon. And SpaceX delayed the launch once on the Falcon 9. They've now delayed it indefinitely. We don't know what the problem is, but presumably this will launch quite soon. Very important mission for Japan, very important for commercial spaceflight. Also, as part of this launch, there will be the Flashlight orbiter, which will use a laser to shine down into those craters that are in permanent darkness at the south pole of the moon to see if there really is ice in those craters and if it's on the surface. And if there is ice there that's in permanent shadow, that could be absolutely invaluable for future human settlers of the moon. So let's hope that they manage to launch that soon. We're not quite, as I said, we're not quite sure what the problem is, but it's very unusual for SpaceX to have problems with the Falcon 9 because it is an exceptionally reliable rocket, as we know.
Andy, do you know if that image that you just maybe you don't know, but is that an actual? I mean, of course, not on the moon, but is that what the lander will look like, or is that kind of an artist's conception?
No, that is the official image from iSpace. That's exactly what it's going to look like.
Okay.
Wow. It's about the height of a human and the width of a human, basically. It's not an incredibly huge thing, but that is the official image of what the Hakuto lander looks like.
It would be about the height of a human and the width of a linebacker, I would think.
Yeah, very probably. Two lovely images from Artemis of the Earth and the Moon, which are absolutely gorgeous images. And as you can see, the Moon in the foreground in both images, which is why it looks bigger than the Earth. That hasn't stopped conspiracy theories already going on about that, of course.
Oh, no.
That it's fake. Oh. It has to be fake because the Moon's bigger than the Earth in those images. Yep, I've actually seen that. So there is no hope for some people, is there? And just a reminder that there is the splashdown of Artemis 1 on the 11th of December, next Sunday. It splashes down at 12:40 p.m. EST or 5:40 p.m. GMT. We will be covering it here live on Space Oddities. If you would like to join us, we'll be covering the splashdown live. And this will be an incredible voyage through the atmosphere. Artemis 1 will return from the moon into the Earth's atmosphere, traveling at 24,500 miles an hour. It will briefly dip into the Earth's atmosphere, which will reduce its velocity to 300 miles an hour. It will then exit the atmosphere again and then go back in, and with its velocity greatly slowed, will float down on parachutes for a splashdown. This has never been attempted. This type of re-entry has never been attempted before with a human-rated capsule. So let's hope that everything goes well, and we shall keep our fingers crossed. And you can join us on Sunday, the 11th of December. It's 5:40 p.m. GMT. Well, I suggest what we do. We start the live broadcast about 20 minutes to half an hour before that. So let's say about 5 p.m. GMT next Sunday. Please do come and join us, and we'll cover it live.
Andy, I'm just realizing that I will be at the American Geophysical Union conference in Chicago at that time.
Right.
So if I can, I will try to track down some of my lunar science colleagues. Perhaps we can have a little chat session.
Lou, that would be absolutely wonderful if you could do that. Thank you so much. We'd love that. Absolutely. Okay, so just some words about the competition, guys. Now, don't forget we're running our normal monthly competition. The prize is to win 2 sets of binoculars. Yes, 2 prizes for one lucky winner. A pair of Helios Sport 10x25s compact roof prism binoculars and a pair of Helios 10x50 binoculars. These are wonderful prizes. Now, what do you have to do to win that? What you have to do, it is aimed at families, as it's a season for families to be together, and really one adult and one child. And what we'd like the adult in the family to do, and it doesn't have to be sort of father and daughter or mother and son, it can be granddaughters and grandparents, it doesn't matter. We'd like the adult to write a short poem or a piece of prose up to 200 words or thereabouts about any astronomical object. It could be singing the praises of an astronomical object. It could be saying how much you detest it. It could be anything. And then the child should do an illustration to go with it. to illustrate the poem or the prose. So we just like you to do a bit of writing. That's all. The poem, if it's a poem, it can be in any style. The drawing or painting can be done in any medium, including computer graphics. And the closing date for this competition is this coming Friday. So we would like you to get it in by the end of Friday, please. And what you should do, you should send your text and your image to our email address, which as ever is spaceodditieslive@gmail.com, entitling it competition entry, to arrive no later than the end of Friday, the 9th of December. Please include your home address in the email so that we know where to send the prize should you so win. And the entry that the Space Oddities panel likes the most will win. We will announce the result a week today on the 12th of December. The winner will be announced. Now, so far, the response to this competition has been absolutely overwhelmingly zero, basically. So even if you don't think what you've done is very good, even if you're the only person to enter the competition, you'll still win the binoculars. So think about that. So get your writing quill out, write something about an astronomical object, 200 words or fewer, and get a child in the family to do an image to illustrate it, and pop it over to us, and let's hope you can win. Okay, now also calendar news. Thank you so much to those of you who have bought calendars. 2023 Space Oddities calendar. As you may know, there are postal strikes going on at the moment. We've had a couple of problems with the supplier as well. So we are awaiting delivery of the calendars, and we will send them out to you as soon as they arrive. We're not anticipating this is going to be much before the 18th or 19th of December, the way that things are at the moment with the post. But we will get the calendars out to you as soon as we possibly can. And thank you very much. There is still time to order your calendars. If you would like to order the Space Oddities 2023 calendar, which features 12 images from our viewers gallery, for which we thank the people who submitted them, then you can buy them in the UK and Ireland for the incredibly low price, unrepeatable price of £8, including postage and packing. That's £8 sterling, of course. And all you need to do to buy the 2023 calendar makes a perfect Christmas present. What more could you want? Just make a payment to our PayPal account. And all you need to do is go to PayPal and choose to send money. The email address you need is spaceodditieslive@gmail.com. The name, when you do that, will appear as Darryl Salisbury. That's Daz in disguise, because he set it up. So make a PayPal payment there to spaceodditieslive@gmail.com, and then send us an email to the same address just to let us know that you've paid for it, and give us the address you want the calendar sent to, and we will send them out as soon as they arrive from the publisher. And apologies for the delay.
Buy a couple of calendars, win and win the contest, and your holiday shopping is done.
Absolutely. You see how
about.
easy we make it for you. I mean, we aim to please here at Space Oddities. So you could be the lucky winner of 2 pairs of wonderful binoculars. And yes, Daz.
Just 2 things. The times of the splashdown may vary, so just keep an eye on the
yes.
The news. It all depends upon weather and whether or not they can plonk it down where they want it to. And also, if anybody does have any problems with PayPal, just send an email to spaceodditieslive.com at gmail.com. What we'll do is we'll pass on another method for you to make the payment. So don't worry if you can't do it by PayPal.
And it's great to see you back, Daz, and with your video and sound working. So thank you for joining us.
Yeah.
And
by royal appointment, this is by royal appointment.
Yeah.
My public demanded it.
Absolutely, your public demanded it. But we have to point out, though, that with more people attending next week, you may have connection problems again. But Daz is working on BT. He's going to send the boys round if they don't sort his connection out.
Send the firm round.
Yeah. So we know what BT are like. So good luck with that, Daz. We hope that you can convince them to see the error of their ways and that they don't continue to route your connection through 2 defunct telephone masts in France, which is what they appear to be doing at the moment.
Yeah.
So anyway, it's great to have you back, Daz, and let's hope you can stay. Okay, well, I think that just about brings us to the end for this evening, does it not, guys? Unless anybody wants to say anything else.
Well, I've just got a couple of little things that they're a bit of old news, but one of them was we were talking about Orion, and I think today was the last flyby the Orion capture was actually done of the moon. I don't know whether there was any sort of like thrusters used to correct the course to move it away from the moon. But as you said, it's coming back and it's arriving on Saturday, Sunday. But what I would like to do, none of this would have been possible if it wasn't for a group of 3 men. If you remember at the launch, they found that they had again a hydrogen leak underneath the actual rocket itself.
Yes.
And there was talk about possibly scrubbing. There was to take it back to the vehicle assembly building. But in the end, they decided to send in a group of 3 lads who were called the Red Crew. Now, these lads, they must have nerves of steel. You've got this rocket, this massive rocket above you, that's full of all this hydrogen, oxygen, everything else. It's hissing, it's creaking, it's doing everything else. And they actually went in, and they were underneath the actual rocket itself to basically try and resolve this leak. And what they found is when they got there, there were sort of like 2 plates which, when they're screwed together, form the seal. But what they saw was that visibly the nuts had not been tightened. So what they did is they tightened these nuts to seal and literally within seconds it sealed the leak. And then they came away. And that's the only reason that the SLS was able to take off on that day. These 3 lads, they must have nerves of steel.
Well, I was going to say, Daz, I think after that experience for them, I bet they know all about tightening nuts.
Well, yeah, exactly. I mean, in more ways than one. But yeah, they
gives Titan a bad name, doesn't it?
Sorry?
Yes. Gives Titan a bad name, doesn't it?
Absolutely.
Yeah. So yeah, it was very. I mean, they did do an interview after the event. They did talk to the chaps, and they were saying that even though they were aware of the danger there, because if this thing had exploded, if something had gone wrong, they would nothing would have been found of them. They would have ceased to exist. And the group was led by Trent Ennis. That's ANNIS. And he was the leader of the crew, and the other members were Billy Cairns and Chad Garrett. So hats off to these chaps. They were absolutely fantastic. It was I don't know whether I'll have the bottle to go and do something like that. I'll be in a bunker somewhere. If there's a gas leak anywhere around me, I'll be off. That'll be me on game. The only other thing is that seemed to slip through the net was that NASA have been developing a inflatable heat shield, which they hope to use to land things on like Mars and things like that. And they've actually tested it. It flew a couple of weeks ago, and it is called a hypersonic inflatable aerodynamic deaccelerator, or HIAD. And what this thing does is it goes up, and it can actually be connected to things, or capsules or instruments, and it can be brought back through the Earth's atmosphere. Apparently follows some sort of corkscrew trajectory through the atmosphere. But it's basically, I think it's just sort of like a big fan thing that opens up, and there's to make it a big round heat shield. They tested it with some test equipment on there, and it splashed down successfully. And it's one of the things that they hope to use it for is to retrieve defunct satellites. and recycle either the satellite itself or the products that are in it. Because as we know, these satellites are made of such precious metals, and usually they're just left to burn up in the atmosphere. So anything that brings us back a satellite and we can recover these elements that we are so rare on Earth, then thumbs up from me. That's all I can say. So yes, this shield, it seems to work, and they'll be using it anywhere that's got an atmosphere like Mars to protect any capsules that will be passing through the atmospheres. So I just thought I'd like to mention that.
It's a major step forward in re-entry technology, hopefully.
Yeah, I mean, with that, like you said, the Orion doing the skip thing where it goes into the atmosphere, then pops back out again, then comes in again, and it's literally scrubs off all of the speed. But this is just like I say, another feather in the cap of NASA. So and the teams who developed it.
Yes,
and it's reusable as well. So it's anything that's reusable.
Don't ULA have a view to using it to reclaim or to retrieve the Vulcan engines?
Apparently, it's so large that they can attach it to loads of things. So yes, they probably are. Yeah,
because the Vulcan is going to, at least the initial flights, they're not going to reuse the first stage, and certainly not the engines. But they do want to save the engines, and they're looking at this as a way of saving the engines for reuse. So that will be really interesting. Yeah. Well, listen, viewers out there in YouTube land and Facebook, thank you so much for joining us tonight. It's been great to have your company, as always. Don't forget to like and subscribe. Those of you who have bought the calendars, we will get them out to you as soon as we possibly can. But of course, we don't know what's going to happen with the postal strikes. So we just have to suck it and see, basically. But we will get them out to you as soon as we possibly can. And thank you for your forbearance. If you haven't bought a calendar yet, buy one. If you haven't entered the competition, all you've got to do is to write a poem and or a piece of text about an astronomical object, and get a child in your family to illustrate it. And those 2 pairs of wonderful Helios binoculars could be yours. And Helios is a really good make. Their lenses are absolutely superb. So these binoculars are really worth having. We wouldn't palm you off with any old nonsense. And obviously, we'd like to thank our sponsor, Rother Valley Optics, for supplying one of the pairs of binoculars as this month's prize. Thanks, guys, at RVO. And with that, we will bid you good evening. We will be here on Sunday for the Orion splashdown. If you can't make it then, we'll be back at our normal time next Monday, 8 o'clock UK time. So thank you very much, and tell everybody about us, tell your friends, tell your enemies, and tell everybody in the phone book about us. And we hope you've enjoyed the show. It's been a pleasure to have you watching us. So take care, guys. We will see you on Sunday, but if you don't make that, we will see you on Monday. So from myself and from Daz and from Roger and from Lou, it's a goodbye. Bye-bye. Have a
great day, everybody.
Good night.
See you Sunday.
See you next time.